This could be the age, gender, department, month, and using uses. Okay, now literally we are done giving the label names. Okay, now we also want to go ahead and tell SPSS, okay, this value, these codes we've given you in data view, what do they actually mean? And that's what we do in the value session, right? This might not be the same for those who are using a lower version of SPSS, okay, but it's almost the same thing. Okay, just a little differences. In case you are seeing this, I assume that most of us are conversant with SPSS. Okay, like I said in initial beginning, if you're already familiar, please pardon us when we explain some key basic concepts for people to understand. So SPSS is a tool like Excel. Just a brief recap. It's a tool like Excel that literally is used for analysis. It's a tool like Python. It's also a tool like Power BI. Just that they all have their unique functionalities and their unique experiences they bring into it. Okay, so this is just this brief summary about SPSS. So it's literally used to analyze data, okay, for researchers, for those in academia, and as well for businesses. Okay, this is just the primary use for SPSS. And tomorrow we'll be talking more on R and how it is also used in analysis. Okay, view, we are literally seeing a plus sign and a X sign. The plus sign is just to add your variables and the code they represent. So we literally don't need to do that under the ID because we need code it. So we close that. But for the age, we literally might not need as well to do that because we have not yet grouped our ages, which we'll do subsequently. Okay, and now but gender came in as a code. So we need to tell SPSS what this All right, so we have the males and females. Remember, under the labels, you write the real meaning of those codes, while under the values, you write the codes that corresponds with those labels, right? So we already know that males are 2, females are 2, males are 1. You click OK. Now, if you toggle back to the data view, it's still showing under age 1, 2, 1, 2. But if you check here, this button showing A and 1 is called the value labels. It helps you to toggle between the codes and the label. So now I'll click it, we'll see what will happen. Okay, now it has changed to male and female. So literally now, when SPSS is running this analysis, okay, we could actually see that it will show the males and females, no more the codes. Okay, no more the codes. So let's go ahead to the others. Departments. Okay. All right. So under departments, let's just give a random value. Let's take, for instance, social medicine. Law. See, okay, let's just use that. Let me see. And how many do we have? Okay, let's use biochemistry. Okay, nursing as well. All right, let's give them the code. Just randomly now, let's assume that this is 1, this is 2, this is 3, this is 4, this is 5. Okay. 15 now, it has changed. Okay. Let's just add more values now. If we change, maybe let's add 1, 2, 3. Okay, let's just also add 6, 7, 8, 23, 45. Just a random figure. Okay, 1, 2. Let's have a random of 8 respondents. Okay, months. I just put that. No, okay. Okay. Need this. Okay. Let's work with this. All right. So if you toggle now to the variable view for the months, let's just add, I think we added a very long month. Let's reduce that to 3. It should be a maximum of 5 months. Okay, so we have maximum of 5 months. That means we'll add 5 boxes. So let's just give that January, February, March, April, May. So let's give it 5, 4, 3, 2, 1. Click OK. Okay, and same thing for disease. Okay. So let's assume that there are 8 diseases also. Malaria, the disease is there. Respiratory, eye disorder, dental, eye, okay, eye disorder, skin disorder. Now this is just a manual way of entering this. Of course, we can do this together by importing the data. I think we'll do that lastly before wrap up. So order the one, guys. Okay, respiratory infection. So let's assume that these are what we have here. So we can just name them. Okay. 5. Okay. So our codes are ready now for analysis, but one more thing is missing. We need to give them a measure. Remember when we talked about ordinal, nominal? These are where we indicate those. So if you click now, this could be ID, could be a scale, could be a nominal. We don't literally need it. So let's leave that scale. Age is literally a scale. Gender is a nominal value. Yeah, department, a nominal value. Month, nominal. And this is a nominal. Literally, anyone that doesn't have an order is a nominal value. So with this now, we are done analyzing our codes and interpreting them through SPSS. We now need to run the proper analysis based on our objectives. So just to run the first basic descriptives to understand how many genders we have, how many ages, the age mean, how many diseases we have, and the departments, just a basic descriptives to understand what we have in our data. So you go to Analyze, go to Descriptives, then click on Frequencies. Okay, let's just have this. Let's know the basic descriptives of all our nominal data. We have gender, department, and disease. Okay, now you might not see this print in upper style on other versions, depending on the one you're using. So, but you can click that if you have this. But let's check on statistics. We want nothing of this. We don't need any of this. Mean, median is a nominal value, so we don't need that. Charts, we might need a bar chart just to show us the differences, but in percentage. Okay. And then the formats, still the same thing. Then click on Create as upper style, right? If you have it, so click OK. Now, this protocol, the output of SPSS, what we've been working on is the SPSS or SAV file. Now, this is the SPV file, the output file, where you literally see the output of your results. So, if you can see this now, we have that 5 of our respondents were males, while 3 were females. Okay, I'm using version 29.0. So a percentage, okay, so we are seeing literally here that males are of higher percentage in this population, okay, and then based on our sample. And then the departments, we are seeing that pharmacy had about 37, which is the highest of our samples. So they had a higher representation amongst our population. Furthermore, we can also see that 25% of our data were those whose diseases were recorded in the month of March. So we see that in March, April, in March, May, and January record a high number of diseases. This is just what our descriptives can show us a little bit, but there are other deep things when we start doing comparison of our data. Okay, so we also see now that literally malaria, eye disorder, skin disorder recorded a higher percentage in our population. So we can literally say that malaria, eye disorder, skin disorder had a high prevalence in this particular population. Yourself into SPSS is not possible. It's not really wonderful. It's not even advisable. So it's always best to import, and then it will be easier for you to run your analysis. Now, these are real data now. Let's compare what we analyzed with our fictional data initially with a real data set now. So let's watch now. Of course, we have to give our labels. So, but to save us time, I can just copy from what we have initially, right? Let's just copy from here, right click, copy, just come here and paste. Same thing for the values. It's still the same thing. Let's assume, okay. Oh. Okay. We copy this. Okay, and then paste. Also here. I wish I would copy it. Okay. Okay. So we have the same labels, the same values. Now let's compare that with what we had initially, the fictional data. So still the same process, analyze, descriptive frequency. So someone noticed something. Did someone notice anything around our age? Is there anything you noticed here? Anyone? Our age was signified as nominal, but literally it's not nominal. Remember, our age, like we said, is a scale variable. So literally we have to take back that to scale to be on the safe side when you're running the analysis. So frequency, remove the gender, create an upper style. All our other functions still the same. We don't need this. Mean and median, not needed in nominal. Accept mode, of course. Charts, let's also accept bar chart in percentages, right? Then click on continue. Okay. Yeah, it's coming up. Okay. So let's see. Okay. Let me close up some documents so that we'll have enough space. Don't save. Okay. So let's go again. I think it didn't run. Scale, frequency. still show us how we grouped these ages. Let's go ahead. Percentages. Okay. It takes a little time. I think my system is already heated. Let's see. All right, so we have the first one we ran because empty. Okay. Now, look now. This is the entire data. If you can see here, we have over 498 to be males and 755 to be females. If you check now, there is a number 3 here. This means that we mistakenly added 3 when we were adding coding. These are things you just have to check for when you're doing your data cleaning. So because literally there is no option under gender that is called 3. There is nothing we coded as 3. So obviously this is a mistake. So it's some of the cleaning you would do before reporting your analysis. So of course you have to go back, find where this 3 is, remove it, or remove completely the entire row, or replace it with either male or female. But best practices recommends that you replace unknown values with a mode. And now we have that the mode is females because we recorded over 60% of our population is females. So literally our best practices, we always recommend that you replace either unknown values or missing values with a mode for numerical values. For continuous values, you can use the average. Please do remember this is very crucial, very important. All right, so if you look closely to the departments, the highest department that was represented was that of radiography and medical rehabilitation, which had about 16.6% of the entire population. So we can literally say that a higher percentage of our data came from those departments in rehab and radiography, respectively. And then going further on the months, we could also see that the months that we recorded their highest prevalence of diseases, okay, was July. What's the implication of this? Now, you could actually make a proposal to the community and tell the community, okay, during this season, provide more of these drugs to this community because we've seen that from this data that these people experience a hike in disease prevalence conditions. So let government provide them with medical services, especially in this particular month, as this will help curb or reduce the height of this disease growing in this community. So you see the beauty of analysis when you're presenting them to your stakeholders or to the researcher involved. So let's now go to the diseases. So literally, we are seeing that malaria was most prevalent in this study or in this community. So it recorded over 54%, okay, of the entire population. So we could say that malaria was actually of high prevalence in this community. But of course, you know that this is just a basic descriptive statistics. We can't conclusively say this without running all that complementary tests to confirm our hypothesis, right? And these are what we do in inferential statistics, and this is not what we're going to cover in this short time. Literally, we have 10 minutes to just cover up some things and wrap up. And then tomorrow again, we go on the basic concepts of R. Now, the aim of this entire live exhibition is just to expose us to these concepts and to expose us to the beauty of SPSS and to the beauty of R, and see how we could apply them in our daily lives and even in our academia, for those who are in academia or in our business, okay, to improve our study, to improve our research. Like I said, analysis makes you feel like a prophet, because you can literally predict some things and make intelligent predictions, okay? And these are not just guesswork. These are data that can be verified, and often and most times they come out to be true. Just that sometimes, because they are data, you have to make some tests and retests just to confirm your hypothesis. So let's go on now to the graphs. Now, I said the beauty of graphs is just to show the height or the I know I was reading a book on presentation of graphs, and I found that if your graphical presentation doesn't capture the attention of your reader within the first 5 seconds, then no need for that graphics. So literally, what's the implication of that? That your graphics, someone doesn't need literally to look a second time to your graph to know what's going on there. It's not like a table that someone needs actually to read and understand. So within 5 seconds, there's what we call 5 seconds rule in graphics. So the respondent or the stakeholder needs to understand that what your data is presenting is this within the first 5 seconds that they look at your data or look at your presentation. Okay, these are just important facts that we need to remember when we're presenting studies for publication or for any business stakeholder. It's really important because, of course, you should know that when you read an article online, the first thing you are literally seeing is the abstract, right? But if such person is interested in your study, they literally want to go also to the results section, and to capture their attention, you have to also give them something that will save them time, at least, and know where your study is actually pointing towards. So we also see in the graph here, the month of July had a sky in the disease condition. Okay, we also see in the graph here, disease malaria had the most prevalence, while UTI had the least prevalence in this particular population. So we will literally use the next 7 minutes to take questions.
Thank you for the teaching, sir. It was explanatory, but unfortunately, I lost you along the line. So I have a whole lot of questions. But now, I don't even know where to start asking from.
Yeah.
Well, I got lost when we were analyzing the data. I was not so sure of the options you picked. And the whole variables, the statistics, the charts, everything just...
Okay. Any other question before we take that? Okay. It's just some basic steps that we took. Now, you saw when we imported, literally just go to the file, import. If your data is in Excel format, you click on Excel. If in CSV format, you click on CSV, depending, right? So, and once you import your data, it will be in somewhat this format. Then you have to follow the steps of what labeling and giving SPSS the values for your codes, right? Remember, we said that the best practices is to import codes and not the values, not the words. If you import the words like this, you get a lot of errors in your analysis, and you will be literally frustrated. So it's always best to import your data as values. That way, it will be most conducive for SPSS. Okay. So to analyze the data, very simple. Go to analyze, descriptive, go to frequency. Okay. Then let me just go back again. What I'm doing, I'm holding down Shift and then clicking on the last option. This is to carry all of them together. Then I forward. Okay. Then I clicked on statistics. Assuming that this was a continuous variable like weight, height, age, we will literally be needing the mean, the standard deviation, right? But now we don't need that because they are numerical, they are nominal values. So we just need a chart. So we'll pick bar chart. We click OK. And then the format remains the same. The styles the same. Then this dialog box of create upper style table. It depends on the version you're using. For all of them still produces almost the same result. So not much difference. So once you click OK, you should be able to see similar things as this. So one more thing I needed to show us is how to code age groups. So age groups are literally coded by going to transform. Remember, we coded this age here, 18 to 21, 22 to 25, 26 to 29. How do we go about it, right? So let's just assume we've not done this. Let's do it again and see how it's done. Go to transform, go to recode into different variables. Then insert the age, then give it a new name, age brackets. Okay. Age brackets. You can change that. So click on old values. Now, remember we said age is 18. That's the range to 21. We call it 1. Click on add. That's added that. Then range 22 to 20 what again? 25, I assume. We call it 2. You click on add. Okay. Then finally 26 to 30. Let's call it 3. Click on add. Once you're done with this, you are good to go for coding your age. So click on continue. And then click on OK. If you go back now, you see that age bracket has become another row in the variable view. So all you need to do is to label those groups 18 to 21, 30, 20, sorry, to 25. And then 26 to 30. Yes. So we coded 3, 2, 1. Okay, so if we run this, we could also see the age ranges or age brackets. So let's just use this, and also the charts. Okay, we are seeing the 18 to 20. We are also there. So literally, this all we can see on descriptive. There is more, but this is just to stir up our interest in research analytics and how it can actually help us improve our research studies. If you really appreciate the knowledge you got, please share with others. Caring is sharing, right? Teddy Mapuka, thank you for joining. Emanuela, thank you for joining. Ayele, sorry if I didn't get that name. Okay, Innocent, we can see you. I think you joined early. Thank you for joining. We can see who again? Kiran. Okay, Emanuela, we can see you. Thank you for joining. Okay, Johnson, can see you. And Margaret, our marketing chief. Thank you. Samuel, our publicity chief. Thank you. And everyone, you have a good night rest.